Thanks so much to the organizers for inviting me to this. When I was invited, I mentioned that I don't know a whole lot about computational creativity, and I'm actually pretty skeptical about it, and they said that's fine. So I look forward to discussion and learning more about different people's points of view on it. So in this talk, I'm going to talk about three different things. The first is computer-generated art and my own background and thoughts about that topic. Then my thoughts on computational creativity, and at the end, a little bit of some ideas around creativity research that I'm interested in. So I'll begin by talking about art. Art and creativity I think, are two separate topics, but they share a lot. They have a lot in common. My own background began in undergrad. I had a double major in computer science and art, so I did a lot of painting and a lot of programming. And in grad school, I developed techniques for creating artistic images. So, for example, my first paper was a method that took a photograph as input and would apply brush strokes to it and add more detail in the brush strokes, and finally produce a final painting. So this is an algorithm that I built and designed that implemented some of my own ideas and experience from painting. So it's a completely procedural piece of code that implements my ideas of programming, my ideas of painting. And we built this installation that was shown in some art festivals where you can walk around and the system makes a painting of you. And each image comes from the system. I didn't obviously design the images myself. And often I feel like they can produce unexpectedly nice results. And sometimes there are surprises, like I would produce an image and be like, where did that come from? That's really cool. And then I look at the code and say, oh, I see what the bug was. But often these surprises are kind of the most fun part of the process. And I'm sure anyone who does any kind of graphical programming has had this kind of experience. Because it was kind of hard to figure out how to move forward and develop new painting algorithms, I started to think about working from examples. And so I developed this algorithm called image analogies that would take a pastel drawing and a photograph and apply the style of the drawing to the photograph. And so here the visual style that comes out is a combination of the code and the data in the example image. And again, it's this procedural combination of elements. So I could explain how the algorithm works, but I can't predict exactly what it's going to do in any case. And of course, there's always lots of parameters to tune. There's a lot of author involvement in the final output. So for example, I can adjust with this painting exemplar, I can say I want larger regions and so to capture a coarse style of the brush strokes, or have more fine scale transfer of style from the original. And because it's a learning algorithm, it can do lots of different tasks. So here it was learning to arrange elements in landscape, and again, there's surprising results, exciting, and every time you run a result that kind of works, it's like this sort of very pleasing and satisfying to see this thing that you didn't exactly expect that came out of this code that you wrote. Now, people have looked at results like these and algorithms like these and said, like, the computer's being creative or it's replacing artists. And there's this long history of this same discussion happening over the past 100 to 200 years. People develop new technologies like the photograph, and people think at first that it's a machine that automates what artists do, and when really what it does is it clarifies what artists do. That really the mechanical process of reproducing visual reality is not really the essence of art. And this has just happened over and over again with computer animation, with AI-based art. So here's Harold Cohen at work in the image in the upper right. That we have all these discussions over and over again that people think that superficially making an image is what makes you an artist, and that's really not the case. Now, there's still the possibility that someday we might ever call a computer an artist, and even though now it seems kind of silly to do so. And in order to think about this, people have tried to look at definitions of art, and there's obviously lots of different ways people have tried to define art. And if you're interested in that, I highly recommend this book, The Art Question by Nigel Warburton. But the problem is that these attempts to define art are attempts to explain existing art forms. So it takes a list of things like, why is theater and painting and dance, why are these art, and why is professional sports or cooking not considered arts in the same way. They don't attempt to discuss, so essentially it attempts to build discriminative classifiers. How do we separate the things which we call art from things that are not art? They don't generalize to non-humans. We don't have any examples of things that are not human that are really considered artists. some examples with animals that aren't really relevant. And so any prediction we make about whether computers could create art is we have to take a different approach. And so the way I've thought about it is thinking about why we create art. What is the function of art? And I'm very persuaded by the evolutionary theory of art, and I love this book by Dennis Dutton, The Art Instinct, which I highly recommend. And the basic, evolutionary function of art is argued to be the following: that we use art for sharing and for gifts, for displays of fitness, for mating, for displays of social status and tribal affiliation, as well as for communication. And all of these, especially the first three, but all of these are things that are about our social relationships. There are things that we do to influence how people feel about each other, to please our friends and family, to show affection, to show status or dominance, and so on. And so I hypothesize that art is something that can only be created by agents where we're in these social relationships, or we can have these social relationships. With our computers, we don't really care about how they feel about us, and we don't really we don't get married to them. We don't give them gifts in the same way that we do with people. And until that changes, I don't see why we would ever care about their art or see them as independent artists either. Now, if we have human-level AI, they could be artists, but this is pure science fiction. A world in which we have human-level AI is going to be something so different from our own world, and we have so little idea of what that world or what that software is like, that it's hard to even imagine what that discussion would be like. It's science fiction. It's not really a scientific discussion, in my opinion. So with that background, now I want to turn to the topic of creativity. And I should say that I've read some papers in creativity, but I don't really have a full sense of the field. So I definitely am very interested to hear other people's points of view. That's part of why I'm glad to be part of this workshop. I have not found a clear description where people have written why they think this is worth studying, what the purpose is, and why they think it's possible. So for myself, I can imagine a couple of reasons why you'd want to study computational creativity. The first is that simply creativity is part of human intelligence, and that itself is a sign that it is something worth exploring. We could try to make computers that are creative in the same way as people are, and we could try to use the behaviors of creative people to inspire tools for our own open-ended explorations. That is, to build better tools for people. As for that second point, I'm really skeptical that computers can really be creative or be called creative in the same way that people can. And so why is that? So, well, I've seen there's sort of two ways that people have argued for creativity. The first is what I would call attribute theories, that we can make a list of, what we will do is we will identify what are the properties of a creative work. When someone does something that's creative, what causes that? Well, the work is surprising, it's valuable, it involves disparate analogies between different topics. And then it's argued that if we can build a system that satisfies all the properties or creates works that are surprising and valuable and so on, then we made a creative system. But I think we already have those things. We already have software that produces surprising outputs, that produces good outputs. The examples I showed earlier, I was very surprised by the results I got at various times. And then I would look at my code and say, oh, that's where that came from. Just because we're surprised by the results doesn't make them creative. So I really think that authorship and the context around the work are also important parts of creativity, that we should care about who made it and what was the process. And just to give a few more examples, there was this work called Creative Sparks a long time ago, where the authors devised a very mechanical process for devising ads with analogies like, we want to show that this shoe is soft and cushiony, so we'll show some firefighters around it, making an analogy to sort of firefighters catching people in a trampoline. And they would propose, their very mechanical process would propose ads like this, where showing that a shoe is soft and cushiony because it looks like a pillow. And the process didn't involve computers. It's a very simple mechanical process. The results were rated as creative by marketing and advertising professionals, even though there's no automation in it as well. It's just a mechanical, tabulation process. And it's something that once you understand the process, of course you would not say this thing is creative, but people called the results creative when they didn't know where it came from. I think another useful example is the Mail Bros app. This is something that is just endlessly fascinating and mesmerizing. You can just watch it for a really long time and keep seeing new patterns and new structures that just look really wonderful. And if a human artist 100 years ago had created these images, I think there'd be a lot of interest and a lot of appreciation for the beauty and creativity of that work. What created this? Well, it's basically 10 lines of code. It's a very simple algorithm. You can understand at a high level what the algorithm is doing very simply. And I don't see how you could say that this piece of code is creative, and yet if you just look at the images, they just seem so wonderful if they had made by an artist who was not working in this context. And we've seen also many examples in artificial agents and creatures where people say that this work is surprisingly creative, that you run an optimization that produces surprising results, and we call it creative. And for example, in Carl Simms's work, he tried to optimize agents to perform locomotion tasks at a certain velocity, move across, maximize ground velocity, and he gets these surprising outcomes that he didn't expect, and are kind of delightful to watch. These sort of agents that seem lifelike, because we as humans have just a strong urge to anthropomorphize systems that seem active, and so just because they seem like active agents doesn't mean that they're really alive. And once you understand in these optimization processes what happened, you say, oh, well, of course it produced this outcome given these inputs. It's still a deterministic process, even if the results were surprising to begin with. So what about modeling behaviors? Well, I really think that ultimately creativity is not an objective attribute. When we say that a person is being creative, we say that this is basically a compliment. So like, oh, it's a really clever thing that you did, or that's totally awesome. It's a way of giving praise. It's a way of describing our values in a way. When we say Mozart or Einstein was a creative genius, we're valorizing desirable traits. We're saying this person made good choices in their life. And so I really think in some way it's for people. It's not for machines. And maybe I don't know exactly how to articulate that. It's about how relationships with people. It's about people are autonomous and they're making decisions and building and improving their life or improving their decision-making process in some really valuable, desirable way. And we're putting a label on that. And whatever that is, it's not something that you can give to a machine, which is blindly following the instructions that we give it. And that's what all of our machines do. Now, I think there's actually some danger and some reasons why it may be irresponsible to say that computers are creative or that they're artists. And the reason is that there are many societal dangers to treating AI systems as if they are actually intelligent. We see many examples in our society now of systems deployed in ways that harm people through face recognition and through the judicial process and through filter bubbles and so on. And in many of these processes, people are able to hide behind the notion of it's just an AI creating the system or algorithms cannot be biased. The more that people are able to diffuse responsibility for decision-making systems onto software, the more that we have these potentials for harm. And when we say that AIs are creative or intelligent, we're essentially giving the impression that they can be intelligent. I think when you say that a computer is creative, for a layperson who doesn't understand how software works, you're giving the impression that that system is autonomous and intelligent. And we have a huge misunderstanding going on in our society about how algorithms work. And creative AI can support this misunderstanding. Now you can say this discussion we're having here is purely academic. It's not a public discussion, but I think that this academic discourse does leak into the public sphere. We see newspaper articles and startup pitches that are basically taking language directly from academic papers or from artist statements and not translating them from the academic language to the public language. And so this danger is real. And so I would definitely avoid calling any computer system creative. Now, what about creative behaviors? What if we could implement a system that implements the same behaviors and the same kind of lateral thinking or whatever it is creative people do, lateral thinking or analogies or connecting disparate topics or staying up late and drinking absinthe or whatever. But whatever we do, whenever we build these systems, they're still dumb machines following the instructions we give it. They're not initiating the behavior. They don't have their own value systems. They're not doing anything other than following the instructions that we gave them. So I still wouldn't call them creative. That being said, I am interested in the idea of using creative behaviors to build more interesting tools for open-ended exploration. I'll mention two things. So since the workshop description mentioned ambiguity, I'll mention one project we have in exploring ambiguity. So there's this website called Artbreeder, which is built by Joel Simon, and inspired by some of the open-ended exploration ideas of Kenneth Stanley. And Artbreeder is this wonderful tool for exploring images, especially really ambiguous and artistic images. And we built using these images, we built a crowdsourced mechanism to evoke which images are most ambiguous or evocative. So we asked crowd workers to describe images, and for these images here, people will describe them in very uniform ways. There's not a lot of variety in how they describe them. For these Artbreeder images, people will describe these images in very, very different ways. They have like a long list of associations. And so we measure this and report that these images are the ones that are sort of most evocative from this data set. And in fact, we find that images are more evocative when they're a little bit realistic. The images on the top are more evocative and produce more diverse associations than the more abstract ones at the bottom. So essentially, we have a way of kind of measuring and describing ambiguity and evocativeness in images. And we can also categorize images more finely. These are images that start out very ambiguous at the beginning and resolve a little bit over time. People have more consistent descriptions after a few seconds of looking at them. Finally, one other thing I find really interesting is curiosity-driven search. So this has been explored in the world of game playing. In sort of conventional game playing approaches, you might optimize an agent to get a high score or solve all of the levels. In curiosity-driven search, you don't give the system its reward. You just tell it, explore the world as much as possible and try to see as many different things as you can. And having trained these systems, they are then evaluated by then seeing how well it can perform a task. And it turns out that the systems trained to be curious and explore are then better at solving actual tasks like pass the levels than a system just directly trained to optimize a level. So to summarize, I don't think computers can be creative because I think creativity is, for now, a really human attribute. And I think it's irresponsible to call computers creative because it gives lay people the wrong impression about the nature of AI software. I do think creative behaviors are worth modeling. I'm interested to see what other people are doing. And of course, this is all my own opinion, and I'm really curious and interested to see other people's viewpoints on these topics and where other people are coming from.